Welcome to Chapter 4, Business Intelligence, BI, Tools for Data Analysis. Introduction. Data analysis has become more important in the business world. Microsoft and other software companies have created better tools for analyzing data, also known as creating business intelligence, BI. Microsoft add-ins for Excel, Power BI Suite, Power Query, Power Pivot, Power View, Power Map. These are all known as self-service BI add-ins, meaning people who need to analyze data for their job no longer needs to rely on the IT department to get results they need right away. Other BI tools, analysis tools in Microsoft SQL Server database, software called SQL Server Analysis Server, SSAS. Microsoft standalone package, Power BI. There is an emphasis on data visualization where data are shown graphically in new and imaginative ways. Software packages Tableau Public is a non-Microsoft product. Tableau Public, powerful, easy to use, and free. Importing data into Excel with Power Query. Data sets to be analyzed are often stored somewhere else, not in Excel workbooks. You must learn a method for importing data into Excel. The most recent tools are better and easier than in past. These tools are often referred to as Power Query. Introduction to relational databases. Data sets discussed in previous chapters were single table databases known as flat files, where all the data are held in a single rectangular table. More generally, a database is a set of related tables where each table is a data set for the type of discussion discussed in the previous chapter. Because the tables are related, this type of database is called a relational database. Two questions. Why are data often stored in multiple tables rather than a single large table? How are tables related? If all the data is stored in a single large table, this would inflate the size of the database and also introduce the possibilities of error. Because every individual is given a unique line, if one individual's information changes, like their address, this change must be made everywhere that person exists in the table. The solution is split the database into separate tables that are related through the use of keys. Primary key is a field in a database that the server serves as a unique identifier. For example, social security number or individual's last name followed by a number suffix. Auto number, primary key that automatically assigns consecutive integers values. Foreign key, a field in a database table that is related to a primary key in another table. The value of this key has no intrinsic meaning. It's used only for lookup purposes. The actual values in primary and key fields are often meaningless, but they serve their purpose for related table. The whole purpose of separating data into separate tables as a rational database is to avoid redundancy. Each table contains data about a specific entry, such as customers' products, orders, and so on. Primary and foreign keys are necessary to relate tables. Introduction to the relational database. Types of relational, one-to-many relationship. A relationship between two tables where each record is one table can be associated for many records, many tables, but where each record is the many tables can be associated with only one record and one table. Many-to-many relationship, a relationship between two tables where each record and each table can be associated with many other tables. Examples, one-to-many relationship. The relationship between donors and the donations they make is a one-to-many. Many-to-many relationship, the relationship between orders and products from a online store. A specific order can have many products and a specific product can have many orders. The tables are related with linking tables, also called a bridge table, that might be called order details. This linking tables will have at least 2 foreign keys and one for the other product, possibly nothing else. Tables and relationships between them are usually shown in a relational data diagram. Here's the relational diagram between donors and donations. Here's a relational diagram between orders, order detail. So you have many products, you can have many orders, and you have the order date over here. Introduction to a relational database. Until recently, all multi-table relational databases were stored in a Relational Database Management System, RDBMS. This software that created and manages database. For example, Microsoft Access, which is a desktop system where your database files can reside locally on your hard drive. Server-based systems are more common in corporate settings where the databases are stored on a server and usually managed by a database administrator, DBA. To access the data, you typically need to log in with an appropriate credentials. Examples of such systems: Microsoft SQL Server, Oracle Database, IBM DB2, MySQL. Data are usually stored in an RDBMS, but data analysis typically won't want to perform their own analysis in Excel. Technology has been developed to import data from an RDBMS to Excel. These technologies involve more than one queries, where a query specifies the exact data which you want to import. Queries are also common that the language for queries was developed by over 30 years ago. This language is called SQL, or Structured Query Language, SQL. The power of SQL is that with minor modification, it can be used to query any RDBMS. However, it presents hurdles for many Excel users who don't know SQL, so Microsoft and others companies have been trying to make queries easier by creating a transparent layer called Power Query. It has always been possible to create multiple tables relationships directly in Excel. Each table is a single table database. To relate them, you can use VLOOKUP functions. This VLOOKUP method is frequently used, but can be cumbersome. Also, tables might be too large to fit into Excel, approximately 1 million rows limit. From here on, we'll discuss and screenshot. We'll focus on Excel as part of Office 365 for Windows, which contains all Power BI tools, including Power Query. Excel's data model. When you run a query to import data into Excel, you must decide where you want to store the data. Until recently, there was 2 options in a basic Excel table and to a pivot table or pivot chart report. The first option is often a good one unless the size of the import data is larger than the size of the Excel worksheet. The second option makes sense if your eventual goal is to analyze the data with pivot tables and pivot charts. There's now a third option, data model in Excel. A data model essentially mimics the behavior in RDBMS, but all within Excel. Data model stores related tables in a special type of compressed format, not an Excel worksheet, for creating pivot reports. This means you can store all your data, even millions of rows, inside of an Excel workbook, and then use Excel's powerful tools to analyze the data. No VLOOKUP are necessary, and once the data are in Excel, there's no further need for access or any of the RDBMS. Before Excel's relatively new data model, relational data had to be imported from Access or other relational database packages into Excel. Now, relational databases can be stored in Excel directly where they can be analyzed. In short, data model is a relational database that is stored in Excel. To use Power Query to import the consto table and store in geographical files in a data solution. The following steps to be used to obtain the results. Import that file. Solution. Open up the new workbook in Excel. If the developer tab isn't visible, right tab on any of the ribbon selecting custom ribbon and check for the developer item in the right pane of the resulting dialog box. The developer ribbon has been useful for programmers but also provides an easy way to get Excel add-ins to the list. Click COM add-ins on the developer ribbon and check the Microsoft Power Pivot for Excel items. This creates a Power Pivot tab. An associate ribbon, you'll need Power Pivots to see import data. On the data ribbon, click Get Data, then from the database, Microsoft Access Database, maneuver to the Contoso file and import. This opens the Navigator window, fills in as many shown, checking the select box items and checking all 5 tables. When all tables is selected, you'll see a preview of the data plane. This is what it's going to look like when it brings it in. Solution. From the Load drop-down list, select Load To. This opens the import dialog box, fills it out as shown, selecting only Create Connection and checking the bottom data model option. A query and connection pane with 5 queries, 1 for each table, will open in Excel, but when the data has finished downloading, you won't see any of the data read on. Solution. Because you filled out the import data dialog box, the data don't appear in Excel table or pivot table. Instead, they are stored in a data model. To see the data model, select Manage from the pivot table ribbon. This opens the Power Pivot window where you can see the imported data. This looks like an Excel workbook with a tab for each of it, quite different. And you can see why it looks like similar Excel, but you're really not in Excel. Did you notice the 2 buttons circled at the bottom right? Those are toggles between, let's go back, and they're down in here. Click the diagram button at the bottom right and then resize the tables to appropriate to see the relationship diagram. Although these tables are related in the access source file, they're through primary and foreign key. They aren't automatically linked with the arrows shown in the figure. However, you can drag from the obvious key fields to create these arrows and hence related tables. So this is what the relational data, all the tables and how they're linked together. It creates this for us. Back into the solution, back into the Excel window, click from the text to SCV. On the data ribbon, maneuver to the geographical SCV file, click Load, and again fill out the dialog box. Then repeat this for the stores data. This time select the file from the Get Data drop-down list, choose from the workbook, and maneuver from the Sales Excel file. Once again, fill out the dialog box. Solution. Open diagram view and Power Pivot tables. You'll see a new geographic and stores table, but they won't be related to anything. To relate them, drag the stores key into the sales table and store a key in the stores table, and then drag geographic keys into the geographic location, and so on. And so as you see, we added in the tables, and they provide the links with the primary key or secondary key, one to many or many to many. Data table. Most data models will include a separate dates table, even if the dates of transaction are already listed. The purpose of the dates table is to list all possible dates and many possible queries. Year, quarter, month number, month name, day of the week, whether it is a weekday, whether it's a holiday, and so on. Objectives: create a data model by creating a pivot table with a baseball data, and in the process to relate to two tables. The following steps are required. You can see the results of the baseball salaries with the team info finished at Excel. Open the baseball salaries with Team 1. Select any cell in the salary table, pivot table, and insert a ribbon. Fill out the resulting dialog box, making sure that the data model option near the bottom is okay. Creating a pivot table, select your table and where you want it to be. Solution: as usual, a new sheet with the blank pivot table will open, but sometimes something else happens. If you open the Power Pivot window, you'll see that the table from the salary sheet has been added to a new data model. Back in the pivot table sheet in Excel, drag salary to values in this area. At this point, the active link at the top of the pivot table fields pane is active, boldface, and only the fields in the salary table are listed. But now click the all link, all fields, and both tables are then listed. Pivot tables, you can see the fields, and here we have the division selected by team. Expand the team table list and check the division field, the goal being to find the sum of the salaries in each of the 6 divisions. However, because the two tables are not yet related, you'll see a warning in yellow. Also, the pivot table values will be wrong because Excel is unable to combine data from two tables that aren't related. Solution: to fix the problem, double-click the Auto Detect button. In this case, Excel has the intelligence to recognize that the teams field in the two tables serves as a key field, so it uses them to relate the tables. Nevertheless, it lets you examine the relationship. To do this, click Manage Relationship button on the resulting dialog box, and then click Edit to see the dialog. So here we can edit the relationship to see which columns are related to primary and foreign key. Solution: to see what has happened, open the Power Pivot window again. In a diagram view, you'll see both tables linked by their key fields. That is, both tables are now part of the workbook's data model. The only difference between this model and previous examples is the data model has now been created through the pivot table operation, not through the importing and external. Solution: what a surprise. To be safe, save your work, then delete the salaries in the team's sheet. Now manipulate the pivot table any way you like. The pivot table will still work fine. This is because the pivot table source is the data model, and the original data sheet is no longer necessary. Power Query, the tools for querying Power Queries is in the Get and Transfer Data group on the Data ribbon. 3 important strengths of Power Query. You can import data from more sources than ever before. Once you locate the data of interest, you can use the new query edit to shape the data to import it. Your queries are stored in step-by-step fashion so that they can be modified and reused later. Importing relational database. Objective: to learn how to shape a query with a Power Query. Solution: if you select from Microsoft Access database and then maneuver to Consto's database file, you get the navigator where you can select the table of interest. For now, select all 5 tables as before. However, instead of loading the data right away, click the Edit button. This opens the query editor. This lets you preview the data. More importantly, it lets you shape the data imported. Objective: using Power Query, the new and improved web query tool is to import baseball salaries. To import data into Excel, do the following. Click from the Web button on the Data ribbon and paste this URL into the resulting dialog box. The navigator window opens with 2 items on the left document in table 0, and generally more items might be listed, and you can click any of these to preview. The query editor open exactly as in the previous example. At this point, you can delete the junk columns and the rows. Eventually, you will close and load to the option and return to Excel. Excuse me. This is what it looks like when we have it. We uploaded the baseball salaries, and it's in our navigator. Power Pivot. This section discusses the most publicized member of Microsoft's Power BI tool, Power Pivot. The data model and Power Pivot work hand in hand for powerful data analysis. Make sure Power Pivot is loaded in by checking the COM add-ins. It's easy to get back and forth between Excel window and the Power Pivot window. Both can open at the same time. If Power Pivot is loaded, you can click the Power Pivot drop-down arrow in the Power window to see the options in the figures. The feature that sets Power Pivot apart from regular Excel Power Pivot tables is the relatively new data analysis expression, or DAX language, for performing it. The main things you can do with Power Pivot window is calculate columns, add measures, and do each of these with a DAX formula. A calculated column is basically like a new column in Excel based on the data from other columns in the selected table, even columns in a related table. A measure is a summary function for some. Objective: to see what DAX calculated columns and measures look like, how they can be used in the pivot table. Solution: for illustration, we will create two types of calculated columns. You can see the results in the constant pivot table finished. The first is like a typical new column. We'll call it profit calculated sales amount minus returning net. Click anywhere in the right column. The column will add this. Type an equal sign. Click sales amount heading. Type minus. Click the return amount. Type another minus sign. Click total amount. Heading. Press enter. Solution: the default heading for the new column is calculated column 1. This is too generic, so right click and rename it to D-type profit. Alternative: you can combine steps 2 and 3 by typing profit equals sales, bracket, sales amount, bracket, minus sales, bracket, return amount, bracket, to sales, total cost in the formula bar. The second example of a calculated column uses a DAX function, related that it has no counterpart in Excel. It is used to get data into one table from another related table. This function is selected the products table, click anywhere in the first column, and type product category equals related. And you can see here what it looks like. Why would you want to have information on product category and product subcategory in a product table, given that this information already exists in two tables? First, you can now hide the product categories and product subcategories table. Then when you use the data model to create the pivot tables, all the information about the products will be in a single product table, which is less confusing to the user. The second reason is that now you can build a hierarchy in the products table. Do this as follows. Switch to the diagram view in the Power Pivot window. Move the cursor over the product tables. You will see two buttons at the top, Create Hierarchy and Maximize. Click Maximize to expand. You'll see the new hierarchy field in the list and rename products. Then drag the field product subcategory, brand name, and product name in that order, slightly below the hierarchy names and each slightly below the previous field. So it looks like this. We now turn to measures, which are arguably even more important than a calculated column. A measure is a summarization of data intended that it values area of the pivot table. The flexibility of measures created by DAX is the real power in the pivot table. Measures can also be created explicitly, and the only limit is your imagination and your expertise in DAX. There are two ways you can create and measure explicitly. You can type a DAX formula in the Power Pivot table. You can enter it in any table of the data model, but you normally select the table that most closely associated. You can click the Measures drop-down pivot table. These two items allow you to create new measures in existing. Calculated columns, measures, and DAX language. The pivot table functionality that has been part of the Excel for decades is great, but it has its limits in terms of generating the reports that business people need. With Power Pivot, it is a DAX language. These limits are expanded significantly. It takes a lot of work to learn and master DAX, but this work is well worth the effort. DAX experts are high in demand. Data visualization with Tableau, public. In this section, we'll discuss the popular non-Microsoft Tableau public. To use Tableau public, you will typically go through the following steps to create and publish a Tableau called a Vizzies. Connect to an external data. For our purpose, this will be data from our Excel workbook, but other data sources are possible. If necessary, manipulate the data into useful forms for visualization. Create one or more charts based on the data. Optionally, combine charts in the data dashboard, a set of related charts or stories, somewhat like PowerPoint presentation. Publish your Visio to the web. To learn the mechanics of Tableau public, creating a Viz baseball team salaries. Solution. The first step is connect to the Excel file. Open your Tableau public. You can see a connect pane in the left where you can select Microsoft Excel and navigate to the baseball team. Keep in mind that this only creates a connection to the Excel. Anything you do with the data in Tableau public will not reflect in the Excel source, which doesn't change at all. You'll see the Excel sheet listed on the left of the Tableau window. We want all the salaries to 20X, 201X sheets to be joined with the teams. To do this, select the salary 201X sheets, select the first, then while holding the Shift key, select the last and drag them over. This creates a union of all the salaries for 2010 beyond sheets where the data for all the years are stacked on top of each other, and then drag the team sheet to the right of the salaries and union. This joins them through the team key field on all sheets. For the second step, manipulating and importing data, there's a very little to do from this example. There is a row for each player in each year, exactly what you want. However, there's a couple minor changes to make. The symbol above each field name indicates that the data type, but these can be changed. Specifically, year field type is currently numeric, but to create line charts, you need to be date. So click the pound sign and change that to type data. Several columns won't be used for any chart, so you can be hidden. To do this, to drop down menu. Above the arrow fields, hide, do this for the name, sheet, table, name, teams, fields. Now it's time to create some charts. You can see create the first one by clicking sheet 1. All fields appear on the left, and this can be dragged to various pages, filters, and columns and rows in sheet 1 area. This is what it would look like. Tableau Public uses terminology that has become common in data analysis, dimensions, and measures. Essentially, measures are a numeric field. You want to summarize the dimensions of a field you can break measures down by. In terms of pivot table, measures and fields are typically dragged to the values area, and the dimensions in the fields you typically drag to the rows and columns. In the current example, Tableau Public has created a hierarchy, country, state, province, city for the team location. Each has automatically generated latitude, longitude measures from the location dimensions for use in maps. The first chart will be a map of the United States and Lower Canada with the bubbles for each team. Each team will be sized in color, indicating team's relative total salary. Next chart will include a series of line charts, one for each team, that shows the team salaries through the years. And the final chart will show a column chart, one for each year, showing on the average salary for each position. The final step in this example before publishing to the web is to combine the three charts into one. Data cleansing. When you study statistics in a course, the data sets you analyze have all been carefully prepared for your textbook authors, for your instructor. For that reason, they're usually in good shape. You cannot count on real-world data to be set so perfect. This is especially the case when you obtain data from external sources such as the web. There can be all sorts of problems with the data, and it is your responsibility to correct these problems before you do a serious analysis. The initial step, called data cleansing, can be tedious, but can prevent total misleading results. Cleansing data requires careful detective work to uncover all possible errors that might be present. Once an error is found, it is not always easy to clear how to correct it. A case in point, missing data. For example, some respondents to a questionnaire, when asked if their annual income, might leave this box blank. How would you treat this in the questionnaires to perform your analysis? Objective is to find and fix this company's data. Solution. We purposely constructed this data set to have a number of problems, all of which you might encounter in a real set. We begin with the Social Security number. Presumably, all 1,500 have distinct customers are distinct, and people of 1,500 should be different. How can we tell that? Sort on the Social Security column. Once the Social Security column is sorted, enter columns if B3 equals B2, 1 or 0. So J3, copy this formula down, and this will give you that. Enter the formula equals sum J3 through J501 in cell 2 to see if there's any duplicate Social Security numbers. You can see there are 2 pairs of duplicate numbers. To find duplicates, select the range from J3 down and select Find from Select drop-down menu on the home with the resulting dialog box filled in. The particular, make sure the bottom box has values selected. Click the Find Next button twice to find the offenders. 369 and 618 each have Social Security number 283, 42, 4994, and customer 159 and 460 each have 680, 00, 1375. At this point, the company should check the Social Security of these 4 customers, which are hopefully available from another source and can be corrected. Some other problems can occur. Missing birth dates, where simple enter is 999, which is where the format has dates. Negative ages, text entries that begin with spaces, entries that are interpreted as text rather than numbers. Entering income as 2-digit numbers, assuming that the units are in thousands. Thank you. Chapter 4.